Hello. In the last video, we saw how to upload an ADA program to the NEORV32. In this video, we look at how to write a simple ADA program for the NEORV32 and what goes into it. So, of course, there will be some setup that is missing right now. So, in our case, such as ALR edit, I'll tell you about it as it comes. But first, this is the help folder. So this so we say ALR init and let's call it YT demo. And yeah, we want to create a binary, so a program. So say option 2, short description, YT demo ADA program. License doesn't matter. So yeah, before that, all of it can be found in the this file will be made available in the central tutorial repository, which links to the relevant repositories along with some our Wishbone projects, the IO library which is used by those Wishbone projects, and other video guides that I've created. Alright, so yeah, back to this. Yeah. So this is YouTube demo, so we can go cd demo. So we can do ALR edit, and this will automatically open up VS Code for me. You'll need to set it up. I think so. It comes up automatically the first time you run this command. Anyways, I've also installed the ADA and Spark extensions. So as you can see, like Citizen extensions, yeah, ADA and Spark extensions. By so yeah, which is nice. So alright, so the first before development, there will be a lot of files that will there will be two files that we need to modify every time we create a new program like this. So first is we need to modify the GPR file. I do not suggest that you copy paste programs itself, like because of the .gpr files and such. I suggest that you create a new program every time and then copy over any source files that you need. But yeah, so this is so first we'll modify the project GPR file. I suggest so go back to the demos program folder, and we'll just copy paste the files from here. So in the GPR file, so we want to include the NEORV32 HAL GPR, so the ADA NEORV32 hardware abstraction layer, and the bare runtime project. Just say Control C, just paste it. Yeah. We also want to use like the target architecture is RISC-V 64, so we'll select that as well. Runtime environment data. So for our compiler switches, we want to use GNAT 2022. This is there. I just use it because I do for convention's sake. There are more flags available, such as most notably the optimization flag -0, 0, 1, 2 or and 3. So I suggest you search up about those and learn about them independently. Anyways, yeah, so this is compiler, and this is the linker script. So we want to use the linker script that we modified in the first video of this playlist, where we resize the IMM and DMEM to 128K. Even if you did not modify those values, you still need to use that linker script. So every time you create a new program, this is what your GPR file will look like. Of course, if you are using more libraries or if you are using compiler flags, there will be those minor changes. But this is like the bare minimum every time. You'll need to add the linker script, you'll need to add the target and runtime, you'll need to add bare runtime and NEORV32 GPR. Now, this is the first file we modified. Next, we'll want to modify the alia.toml file for the for our program file. So in like YouTube demo, this is the alia.toml file. I again suggest you go back to the demos.gpr file, open the alia.toml file, and you select the depends on and the pins configuration variables. So this basically imports the NEORV32 HAL in the in like the local file system, because the NEORV32 HAL is as of like March 29th is not yet available on the Alia index. So you need not do it for bare runtime. That will be downloaded and imported automatically, but for HAL we need to do this. For any other libraries that you develop yourself, for example, if you follow the NEORV32 plus NPU demo, like a playlist, it's like so in there too, that we need to import the input output helper library, which again is like, okay, depends on pins variables. Anyways, so these are the two things that are the bare minimum. In the source folder, this is a valid basic program, so at least that's what you'll think the first time around. So let's just go ALR build like we did for the demos program, and yeah, firstly let's focus on, okay, it just imported these automatically, RV32 and bare HAL and the bare runtime. It's like the highlights here. Now you'll see, okay, this like undefined reference to gnet exists. I to this date I am unsure exactly what this means, but I just know how to get it to work, and which is just having a runtime support these files. So like runtime support.adb, which is just defines an exit handler. So these files will be available. I just typed them out already, so then I can just copy and paste them in, so we can move quicker. So just say in the source folder, paste them in the source folder. You may also want to actually delete it from this in case there are any. So in YouTube demo source, we go back to the VS Code window. Now we have runtime support, and this is the exit handler that's needed. So like reference to gnet exist, and we want to reference this. So with runtime support, use runtime support, done. ALR build, and it's still failed. So we can resist undefined reference to char. Okay, so we are getting an error from bare runtime. It's yeah, so it's like undefined reference to put char, and yeah, so this is subtle error, a problematic error from, I should have explained it better. We also need to import certain NEORV32 dependencies. So for example, and we would have done it later anyway. So NEORV32 so the NEORV32 itself, the SVD generated from the SVD bindings, and the UART peripheral for the NEORV32. So this is the bindings, and this is the peripheral file defined. It's like a peripherals UART0.ads. This is this. Wherever is the SVD, is the NEORV32.ads, which is called here, which also has a UART0 file, which is called here. Alright. So once you have imported these dependencies, you can go ahead and try to build it again, and now it goes through, thankfully. So going through my history, yeah. So this is the risk by elf obj copy command. We can also just go back to the, this is the main repository. This is the interconnect. Yeah. Let's just go find control F risk 564. Just say copy it. Paste it here. So our now so the program file name is yt demo. Now it will always be the name of the body file, so it's yt demo, and let's call the output binary file yt demo.bin. Since my image gen tool is already on path, I can just call it like I can just call it without any file path or specifications or anything. Go back to the terminal, paste yt demo.bin, call the output yt demo.exe. Okay. Yep, now we have it. So if you go back to the yt demo folder, in the bin folder we have yt demo.exe. We can try, so I'll just reset my board, and we can now try to upload. We'll upload this to the NEORV32. So yt demo bin exe. Running it will of course show nothing because our program is blank. So now what we can do is add something to paste it, like write something out to the terminal. So let's say we want print a string, so we just say import ada.text.io, which is the like printing library. We just use it. So use allows us to like using names. It's similar to using namespace in C++. So it's like okay, we use. Otherwise, like the option is either just you can of course skip not doing it, but like ada dot text.io dot put line hello, or you can do text.io and just call put line. This is better. It's easier, not better, but easier. Alright, so now we have a put line thing. You can just format it off. Alright, so once we have this, let's try again, build the program again and think about what we'll expect. So we'll have build disk by 64, imagine, include it. And here we have it. You are able to print something to the terminal. Alright, so with like this, you can then just go on and build NEORV32 programs. I'll also include an LED blink program on the repository, which like shows you how to control the GPIO output pins of the NEORV32. There's a small subtlety there, but you'll understand after looking at the code is that because probably the HAL SVD to ADA bindings generated on an older version of NEORV32 and the forked or the linked NEORV32 on the setups report does not match anyway. So the output GPIO output pins actually like relate to the input one bank. So yeah, it's that. Yeah, I hope you learned something. As a like a good practice, I suggest you do uart0.init and the baud rate of 19200. This is what I do. The program will still work. It's just something we do. Thank you. This was it for like writing programs and getting something onto the NEORV32. So the repositories linked on the linked in the tutorial repository, that like links to more Wishbone projects. And in there, if you look at, for example, the NPU demo video, or the camera controller demos, like example folders, or ADA files folders, you'll see how to import like more libraries and such, that and write a more complex program. Anyways, there will be a separate playlist for how to going over an example NeoRV32 plus NPU program. Thank you.